All right, welcome everybody. This is week 4. IM1B Essentials. We are going to go ahead and hop right into it. On today's agenda, we are going over the Unit 5 practice test, and then we're going to go over that first performance task. Remember, for this class, you only have to complete one of those tasks. The other one will end up being excused, so you can pick and choose which one you would like to do. And then, as always, we will have a study hall at the end for anyone who would like to stay. Okay, so remember those practice tests for each unit, they are extra credit. So they can really help you improve your accuracy on the test, and they can also, because they're extra credit, improve your grade in the class. So I'm going to give you about 30 seconds to get that pulled up. You're going to go into MathSpace and pull up the Unit 5 practice test. Hello, welcome. Go ahead and open up the Unit 5 practice test if you're just coming in. We are going to be doing the Unit 5 practice test today, and then we are going to go over the performance task as well. Hi, welcome. If you're coming in late, you need to go ahead and open up the Unit 5 practice test. We are going to get started in about 10 seconds. All right, so number 1 says fill in the missing coordinate in each ordered pair so that the pair is a solution to the equation y equals 3 to the power of x. So remember, each ordered pair always comes in the form x and then y. So looking at these, they're either giving you the x or the y, and then you have to find the other one. So in 1a, it's giving us x, and we need to find y. So in order to do that, we're going to plug x into that equation and then solve for y. So our original equation is y equals 3 to the power of x. We are given the value of x, so we're going to plug it in for x there. So we're going to have y equals 3 to the power of 2. 3 to the power of 2 is just 3 times 3, which is 9. So that means y equals 9. So that ordered pair is going to be 2, 9. Okay, moving on to the next one, they give us our y value. They're saying the y value is 3. So now, instead of plugging in for x, we're going to plug in for the y value. So we're going to have 3 equals 3 to the power of x. And this is where we have to kind of problem solve in our head, and we have to know a little bit about exponents, because we need to know 3 to what power is going to equal 3. Well, we know that 3 to the power of 0 is 1. Anything to the power of 0 is equal to 1. 3 to the power of 1 is going to be just 1, 3. 3 squared is 3 times 3, which is 9. Okay, so now we kind of have enough information to say, oh, well, we want it to equal 3, and we know that 3 to the power of 1 is going to give us that. So x has to equal 1. So our ordered pair here is 1, 3. Okay, now 1c, we are given our value of x and we need to find y. So again, we're going to plug it in for the x value. So we have y equals 3 to the power of -1. So remember those negative exponents turn us into a fraction and bring that to the bottom of the fraction. So it's going to be y equals 1 over, and now we just plug this in, but our exponent becomes positive. So 3 to the power of 1. We know 3 to the power of 1 is just 3. So this is y equals 1 over 3. So our y value is 3. Okay, and then that last one, we need to find x. We're given y. So we have 1 over 27 equals 3 to the power of x. Because we have a fraction, we know that this exponent is going to be negative because this is a fraction. Okay, so we know it's got to be negative, and then we need to figure out 3 to the power of what number equals 27. Well, so we kind of started a little pattern or a little list up here. We've got 3 cubed is 9, or 3 squared is 9. So what would 3 cubed be? It would be 3 times 3 times 3. 3 times 3 is 9 times 3. Oh, sorry. This should be 27. Sorry, Paloma, you are correct. This should have been 1/3. For some reason, when I transferred the answer here, I did not write it correctly, and I apologize for that. So when you submit it, you just need to leave me a little note that that was my bad on your score, so you'll still get that 100%. Okay, so this was the final answer, and for some reason, when I wrote it in the box, I just put 3 instead of 1/3. Okay, let's go back to this problem that we're doing, the last one. So we know 3 cubed equals 27, but we don't want just 27. We want 1 over 27. And so to make it 1 over 27, it has to be negative. So it's got to be 3 to the negative 3. So that means x is negative 3. Thank you for catching that mistake for me. And we are going to go ahead and move on. If at any point I'm going a little too quick, please let me know and I will slow it down. I'm not sure why that little link is on the words there, but I will just read through it. Okay. This one says, consider the graph of the equation y equals 2 to the x. It says y equals 2 to the power of x. All right. So 2a says, what can we say about the y value of every point on the graph? Okay, before we even try to read the answers here, let's look at the graph and see what's going on. This is an exponential graph, and we can see that our horizontal asymptote is here on the y-axis at y equals 0. Okay, the horizontal asymptote tells me that nothing will ever touch or go down below that asymptote. Okay, so all of our points are going to be up above the x-axis, which means all of our y values are going to be, if they're above 0, that means they're all positive, right? So looking at these options here, we've got the y value of most of the points is greater than 1. Not true. Okay, we have some points greater than 1 this way. We have some points that are less than 1 going that way. Neither is most. Okay, both of the lines going to go on and on forever in both directions. The y value of every point on the graph is an integer. Not true. Some of them are rational numbers. The y value of most points on the graph is positive, and the y value at one point is 0. The y value at one point is 0. Okay, we are never ever going to touch where y equals 0. So that one is not true. That leaves us with the last one. The y value of every point on the graph is positive. That is the one that is true. Okay, 2b says, as the value of x gets large in the negative direction, what do the values of y approach but never reach? So in the negative direction, that means we're going this way. So as we go this way, the y values are getting closer and closer to -2, no, 2, no, 0. They are getting closer and closer to 0, and they're never going to touch 0. Okay, 2C says, what do we call the horizontal line y equals 0, where y equals 2 to the power of x, gets closer and closer? So they're saying, what is this line? Is it an x-intercept? No. Is it a y-intercept? No. It is the horizontal asymptote of the curve. Okay, number 3, consider the equation y equals 4 to the power of x. Complete the table of values. Okay, so this is going to take some work to fill in this table. So let's start here at the ones that are easier. So first, these numbers in the table are going to be plugged in for x. So 4 to the power of 0, anything to the power of 0 is just 1. Then we have 4 to the power of 1, which is 4. 4 squared, which is 4 times 4, which is 16. And then we've got 4 cubed, which is going to be 4 times 4 times 4, which is going to be 64. Okay, those are the easy ones because they're not negative. Remember, the negative ones are going to give us fractions. So if we've got 4 to the -1, we can just look at this one and make it a fraction. It's 1 over 4. 4 to the -2, we're going to look at this one and make it a fraction. 1 over 16. This one, look at that one and make it a fraction. 1 over 64. Okay, 3b says, using some of these points, graph the equation y equals 4 to the power of x on the number plane. Okay, I'm going to walk you through this. The first thing you're going to do is you're going to grab the point that is attached to that horizontal asymptote. Grab that point and pull it down to the x-axis so that that line is running along the x-axis right here. The next step is grabbing the point that is on the curve and put it at the point on the graph, 1, 4. Okay, so we just took this point and graphed it here. You could have picked anything. You could have also picked 0, 1. You could have picked 216, but 216 would have gone off of the graph that they give you. So these are the two you could have chosen from. I just picked this one. All right, 3C, which of the options completes the statement? As x increases, the y values, all right, let's see what happens. As x increases, so x is increasing this way, y values are going up, right? So they are increasing. These ones are the same, so we're just going to do this one. Which of the following options complete the statement? As x decreases, so as x goes this way, the y values are going down. They're getting closer and closer to 0. So decrease. 3E says, which of the following statements is true? The curve crosses the x-axis at exactly 1 point. That is not true. The curve is never going to cross the x-axis. The curve crosses the x-axis again. The curve does not cross the x-axis. Here we go. The curve never crosses the x-axis. That is the true statement. And then at what value of y does the graph cross the y-axis? So here's your y-axis right here. We cross right there, and the y value there is 1. So y equals 1. Okay, Unit 5 practice. A linear function and exponential function have been drawn on the same coordinate plane. So we've got the linear function here, and then we've got the exponential function here. And I'm going to write this. This one is the linear, and this one is the exponential. Okay, and we know that because the linear is a straight line, the exponential is a curve. Okay, 4a says over any one unit interval of x, by what constant amount does the linear function grow? So we're looking at this one over 1 unit. So if we go from here to here, we want to know how much is that graph growing. So if we start here and we want to know how much did we go up in 1 unit? How much did we go up from 4 to 8? We went up by 4. So this is 4 units. The next one says over any 1 unit interval of x, by what constant ratio does the exponential function grow? So now we're looking at the curve, and I'm going to look at, okay, at 1 unit, we're at 2. At 2 units, the next unit over, we're at 4, and then we're at 8, and then we're at 16. So what's happening to that number every time? It's doubling, which means it's being or that means it's times 2, right? So our constant ratio is 2. We're being multiplied by 2 every time. Would it be correct to state that the linear function always produces greater values than the exponential function? That is not true because in this area here, that exponential is producing greater values. The answer there is no. And then the last one, as x approaches infinity, which means as it goes this way, which function increases more rapidly? So which one's going up faster? That's going to be the exponential function. Hey, Matt and Sharon are saving money using different strategies. The amount each has saved after each month is given by the table of values and the plotted points. So here we have Sharon's savings. She looks like from here to here, she multiplied her savings. From month 1 to month 2, she multiplied her savings times 5. And then to month 3, she multiplied by 5 again. So because we're multiplying by 5 every time, that tells me that this is exponential growth. Now, Matt's savings, he's increasing by a solid amount each time. I don't know exactly what it is because 60, 70, 80, 90. Okay, so he's at $90 here. And then here it looks like he's at maybe 180. So maybe he's increasing by $90 each time. Okay, anyways, this one is a straight line. So that tells me it is linear growth. So if each person continues their pattern of saving, who will be the first to exceed $800 of savings? Well, that's clearly going to be Sharon. Okay, she is multiplying her savings by 5 every time. She's going to get to 800 faster. The next one, which is a little more important, whose savings model is the most realistic in the long run? Well, I don't know many people who could multiply their savings account by 5 every single month. That sounds like, I don't know, maybe only like Bill Gates could do something like that if he had enough invested in the right places. But the average person, not going to be multiplying their savings by 5. Matt's model of saving $90 every month is a little more realistic. Okay, number 6. $6,000 is invested at 8% per year, compounded annually. The table below tracks the growth of the principal over 3 years. So let's look at the table, figure it out. We've got our time period. This is 1 year, 2 year, 3 year. and then value at the beginning of the time period. So in January, that's what the amount is worth. Value at the end of the time period. So December. So the beginning of the year, end of the year. Sometimes it's the year starts at a different time, but we're just for our purposes going to say January and December so that we can kind of understand it a little better. And this is the interest earned in the time period. So that's the amount made. So our increase. Okay. So if we start with 6,000 and we are getting 8% per year, that means we're going to take 6,000 and multiply it by 0.08 to see how much we're making to find A, which is what we want for that first one. So if you can't do that in your head, I can't do that in my head. I'm going to pull up a calculator, clear it out. 6,000 times 0.08. So $480. So in cell A, we're going to need $480. This one was 480. Okay, now what value should go in cell B? Well, if we started with 6,000 and then we increased by 480, we're just adding those together. So we get 6,480. Okay, the next one, what value should go in cell C? So we're looking at here. So if we ended December with this amount, that's going to be these are going to be the same. So this should also be 6,480. So in that box, you got $6,480. And then what value should go in cell D? Well, cell D is the interest earned, and we know that if we started with this amount and if we started with 6,480 and we ended with 6,998, we're going to subtract to find the difference. So 6,998.40 minus 6,480. And again, use your calculator. I think I did that 518.40. So $518.40. Okay. What value should go in cell E? So now we're looking here. We want to find the difference between these two. So we've got 7,558.27 minus 6,998.40. And plug that into your calculator. Get 559.87. Okay, and then 6F says, what is the total interest earned over the 3 years? So we're going to add up all of that interest earned. So we've got 480 plus 518.40 plus 559.87. $1,558.27. Okay, so that should be the final answer there in that last box. All right, and next we are going to look at the math task one. This is the one about school clubs. So I'm going to go ahead and post the link in the chat for anybody who hasn't made their copy yet. Okay. So go ahead and click that link and make that copy. I'm going to do a little bit on here, and then when we get to the graph part, I will switch over and show you guys how to do that on the computer so that you guys know how to complete your graph. All right. High school has two clubs, the Key Club and the Science Club. The Key Club started in their first year with 10 students. The Science Club also started with 20 students in their first year. Each year, the clubs have increased their membership. The Key Club has doubled the number of students. So doubled means times two each year. The Science Club has increased their membership by 40 students, so plus 40. The table shows the number of students in both clubs in the first year. Complete the table showing the number of students in the Key Club and the number of students in the Science Club for years 2 through 6. So looking at Key Club, remember Key Club was the one that doubled, so these are going to be multiplying by 2. So year 1, multiply it by 2, we get 20. Multiply that by 2, we get 40. I'm going to let you guys finish those out. Year 4, we would multiply 40 by 2 and we'd get 80. Multiply 80 by 2, we'd get 160. And then multiply 160 by 2, we would get 320. All right, now looking at the Science Club, these ones we were adding 40 every time. So 20 plus 40 would be 60. 60 plus 40 would be 100. Keep going, see if you can fill out that rest of that table on your own. Plus 40 would be 140 here. Plus 40 again would be 180. And then plus 40 again would be 220. All right, so if you have all those right, you're going to get the 10 points for that question. All right, on the coordinate plane, it says, please show the following. It gives you all the steps to complete. I'm going to go ahead and let me pull up the task here. Okay, so we are on this task. We need to fill out this graph. So it says to edit this graph, double click here. So I'm going to double click on the graph. Why? Oh, I have to make a copy. Go ahead and click make a copy. And you want to change it to your name if you didn't already. I'll put my name here. Make a copy. And you should have already filled out the table. And we should be on the graph part. So you're going to double click on that graph and it should open up something that looks like this. Now our first steps is to label the axes. So this one here is going to be the number of students in the clubs. And this axis here, you just have to double click on it in order to get it to highlight. This one's going to be the number of years. And then while we're doing this, we're also going to make a title and we're going to do club growth per year. So once we have all the labels done, then we can get to work on actually graphing the information. So I'm going to start by making the orange dots are going to represent that key club, the one that was doubling. So looking at our table on year one, the key club had 10 students. So we're going to go year one, 10 students. Year two, we doubled, remember? And so then we had 20 students. Then we doubled again for year three, and that set us at 40 students. Doubled again, and now we had 80 students. Then we doubled again, and we had 160. And then we doubled one more time, and we had 320. Okay. Again, it does not need to be perfect, but try to get it as close to those little crosshairs as possible. All right, now we're going to do the same thing for the science club. Science club started with 20 kids. And then we increased by 40 each time. So we started at 20, increased by 40, that put us at 60. Increased by 40, that put us at 100. Increased by 40, that put us at 140. 180 the next year. And then 220 the next year. Okay, so now you should have all your points plotted. From there, you're going to draw the line. So in order to do the straight line, you're going to use this tool here. And I'm going to pick this point. And I'm going to go all the way. Oops. I need this. Oh my goodness, there we go. Now I'm going to go all the way to that one. So I started at that first point and went to the other one. Now, I want these to be pink. I want them to match. So I'm going to go to line color. I'm going to do that same color as the dots, and I'm going to make mine a little bit thicker by hitting 4px. Okay, so now we have that one done. Now, I accidentally had an extra line there. Okay, so now we're going to do the curved line. So you're going to go to the line tool, but go to that little arrow, pull down next to it, and go to curve. And here you're going to click on each point. So start at this bottom orange one, click on that. Then you're going to click on the next one, and the next one, and the next one, next one. And then on the last one, you're just going to double click and it should stop the line there. And again, I'm going to change the color to match. So I'm going to make it orange and I'm going to make it a little bit thicker. Okay, click on your little arrow again. Now we need to label the two. Oh, why didn't this one go thick? I want it thicker. There we go. Okay, we need to label the two lines. So click on the little text box one. I'm going to first label Key Club, and I'm going to make my box a little bit smaller. I'm going to change the fill color to white so that there's no lines behind it. And then I'm going to add a border that matches my line. Make it a little bit thicker. So now I have the orange box around Key Club that goes with the orange line. And I'm going to do the same thing for the Science Club. So new text box down here by the Science Club line. Make it smaller. I'm going to move it over a little bit. And I'm going to do the inside white. And I'm going to do the background that same pink color and make it a little bit thicker. And there you go. From there, you should be all done with the graph. And if I went too quickly through any of those steps, please feel free to reach out. I can help you figure out how to do those. Okay, so now we are back to our questions. So it says, which club has an exponential growth pattern? That is going to be the club that has the curve. So if you look up at your graph again, the one that had the curve was the Key Club. Explain how you know. I know because the graph was curved and increasing quickly, or rapidly is fine too. Okay, between which 2 years will the number of students in the Key Club surpass the number of students in the Science Club? So if you look at that graph again, and look at where those two lines intersect, they intersect in between years 5 and 6. So between year 5 and year 6, I know because the lines on the graph intersect between those years. Okay, suppose there are 3,000 students in the high school. Assume, wait, did we skip one? Yeah, where's number 5? For some reason, number 5 is not on here. Number 5 asks you to write equations for both of them. And because we haven't covered writing equations for exponential relationships, I'm going to help you with this. So for the Key Club is the exponential equation. You're going to do, I think it says g of x is first. Let me look at this really quick. Yeah, Key Club is going to be f of x. So you're going to write f parentheses of x equals and it's going to be 10 times. And instead of times, if you want to do a 2 in parentheses like that, and then you're going to do a little caret and more parentheses, x minus 1. And I'm actually, for those of you who are here, going to type this in the chat for you. This is a benefit of showing up to class. Some things you get the work done for you. Okay. Hi, Kaylin. We're just working on the performance task. I'm sending one of the answers in the chat. You are just showing up right on time. If you want to go make a copy and get started, I will drop that in the chat for you again as well. But we're starting on number 5, and I'm giving you guys these answers because we haven't actually covered how to write exponential equations. So I'm just kind of giving you guys the answers to these ones. All right, and then for the science club, it's going to be g of x equals, we're increasing by 40, so that means our slope is 40. So we're going to have 40x, and we started with 20 kids, so plus 20. So if you want to just copy and paste those from the chat, those of you that are here, you are welcome to do that. And then we're going to do number 6. Suppose there are 3,000 students in the high school and students can only be in one club, not both. After which year will it become impossible for the two clubs to grow at the rates they have in years 1 through 6? So we're just going to go through and see what would happen. So we've got the Key Club and we've got the Science Club. At year 7, the Key Club is going to double. So 320 times 2 is going to be 640. And the Science Club is going to add 40. And how many did we have in there? Let's see. In year 6, we had 220. So plus 40 is going to be 260. And then in year 8, we're going to double again. So we're going to have 1280 here. And this is going to increase by 40. So we're going to have 300. Year 9, this is going to double. So we're going to have 2530. Wait, no, 2560, I think. Let me double check my math. For some reason, my brain's not working right. We had 1280 times 2. So 2560. I knew I had that right in my head. 2560. And then here we're going to have 600. Oh no, we're not having 600 there. This one's not doubling. That one's just increasing by 40. So this would be 340. Okay, so we still haven't reached that 3,000 yet, but I'm thinking very clearly that in year 10, this one's going to be about 5,000. And this one's going to be already, this is above that 3,000 number. So it's going to be year 10. In year 10, there would be more than 3,000 students. In Key Club alone. So that's not going to work. All right, so you should be done with that performance task now. And we are going to now have study hall. So if you have missing assignments, I will be letting you know in the chat. If not, I will be letting you go. So give me just a moment to check on those of you that are here.